The last two steps in this chapter is about converting the EER diagram into the relational schema diagram. Step number 8 is corresponding to superclass and subclass. Step number 9 is about the union. Let's take a look at this. Step number 8 is actually the only one among all 9 steps that has some choices over here. Some of them will work perfectly with all scenarios, some don't. So you need to pay attention to every single one of that to make sure you understand it fully. And then let's see, how do we convert superclass subclasses into relational schema diagram? There are 4 choices. The first 2 choice has 2 common things. It's about the multiple relations, and it will create superclass and subclasses to form multiple relations. Step number 8 still have multiple relations, but you will have subclasses only. Choice C and choice D has one thing in common. They are single relation, which means one relation handles all superclass and subclasses with some variations. So let's take a look at the first 2 choices, and then we will move on to the other 2. Choice number 8A is indicating multiple relations, superclass and subclasses. So what that's trying to do is this. Let's take a look at an example. We will have an employee as a superclass, secretary, technician, and engineer as subclasses. So when we try to convert that, in our step number 1, we will have our employee converted into a relation already. So when it goes to step number 8, it is time for us to handle those 3 subclasses. For the first choice, we will end up with something very similar to the multi-value attribute, which is step number 6, with one difference. So for a secretary, what we will do is that we will create a secretary relation over here, link with the superclass through the primary key of the superclass. So it will include social security number over here. Underline that, indicating this is the primary key for secretary. Form a foreign key to employee, and then include all of the local attributes. In this case, typing speed. I said this is very similar to multi-value attribute, is that it creates a primary key, forms the foreign key, goes back to the belonging entity. The only difference is that for the multi-value attribute, it will have its attribute, and the primary key of this newly created will underline both. For the subclass, it's different from multi-value attribute. So what it will end up with is that it will only using the primary key goes to the superclass, and whatever local attributes stay as is. So you can see that for technician, it's doing the same thing, still using a social security number, form a foreign key, go back to the employee with its only local attribute. Engineer is doing the same thing. So that is the first choice, which is corresponding to very similar to the original EER diagram over here. So option 8A is going to create a multiple relation. So you can see that we end up with 1, 2, 3, 4 relations, including the superclass and subclasses. So you see that it's a multiple relation, superclass and subclasses. So what you try to do is create a relation L for C with attributes, including in the subclasses, and PK equals to K. Create a relation Li for each subclass. So when we're doing that, the attributes of Li equals to K union with all attributes of Si and the primary key. This option will work for all situations. So this is actually a very good choice that we can have. Create multiple relations with superclass and subclasses. The next choice is going to be multiple relations. Still multiple relations, however, at this time, it has only subclass. So how does that happen? This is saying that we will remove the superclass. So the superclass won't be there anymore, but it will goes to the information stored in the superclass will goes to subclasses. So before we move into the conversion, think about this. What are the attributes describing the car? The attribute describing the car including a maximum speed, number of passengers, vehicle ID, price, license plate number. So all of this will goes to the car. It will be the same thing goes to the truck. So in this case, we can remove the superclass by creating a car subclass, a car entity, and truck entity. And so that is how we will be able to use the second choice here. It's a multiple relations subclass only. To create this in a formal way is create a relation Li, create every subclass for each subclasses. Si goes to all of them with the attributes of Li equals to all of the attributes coming from the superclass union local attributes, and the primary key is the superclass primary key. However, there is one limitation here. This option only works for specialization whose subclasses are total, which means that every entity in the superclass must belong to at least one of the subclasses. In other words, let's take a look at this description here. It has to work with the double line for this specialization. Why is that? Think about this. This is going to give you a double line indicating that all the vehicle need to participate in this specialization, so that all the vehicle will be either in here or in here. Or depending on how we're describing, if we put an O, maybe there's a crossover, then it will appear in here and there. However, if I have a single line here, that's indicating that not all vehicles can belong into a car or a truck. That may be a motorcycle, that may be an airplane, that may be a boat. So it's not belonging to any one of these while we only capture subclasses. That means there are some data in the superclass will be lost. And therefore, that's something we don't want. And therefore, for option 8B, there's only one thing that it cannot work, which means the relationships are not total, which means partial. So this is something very special you need to understand for step 8B here. The next choice, together with the fourth one, is creating a single relation. So only one single relation to handle the things. So that, how do we do that? What it will happen is that we create one big relation. Employee relation including all of the regular attributes coming from the employee, and then we use one attribute. This is the new attribute we created to describe either a secretary or a technician or an engineer. So based on how do we do the specialization, we describe that here. So job type. Therefore, once we create this one, if that person is a secretary, we will put a secretary in job type with the typing speed indicating the local attribute. For T-grade and engineer, in this example will be null for T-grade, null for engineer type because that's a secretary. If this person is a technician, then it will have all of these attributes with a technician here with some values for its T-grade, null value for typing speed, and null value for engineer type. It will be similar things for the engineer. So let's take a look at how is this being described formally. So what this trying to do is that we create a single relation only. So create a single relation with all the attributes of the superclass, and then we also want to include all of the attributes from the subclasses. So all the attributes from subclass 1, all the attributes for subclass N. And then we have this T attribute indicating how did we separate, how do we do the specialization. So the attribute T is called a type of discriminating attribute that indicates the subclasses to which each tuple belongs. The primary key would be the original primary key of the superclass, of course. This has one limitation, indicating that this approach works for disjoint only. In other words, you can only work for D over here because you only have one attribute to hold a secretary or a technician or an engineer. If you put an O over here indicating some employees are secretary and engineer, then that means in that case you need to put two values here, and it is not going to work. And therefore you will have because you only have one variable over here can hold one data, so that this conversion works only for disjoint. Finally, the last choice is the one to handle all situations and then using only one relation. Since we mentioned in earlier slide, because we create that discriminate attribute over there can hold only one data. If it is O, then that means we need multiple values over there. And therefore, this choice is the choice that can handle all the situations while we're creating only one relation. So how do we do that? We simply create flag for each subclass. So you can see that in this case, for the superclass, which is part, we will have all the attributes. The key is the key of the superclass. And then for each subclass, we create a flag. So this is 0 or 1. If this belongs to this one, you get a 1. If you don't, you get a 0. When you get a 0, you will have null values for the corresponding local attributes. If that's a 1, then you will have values in your local attributes. So this case will be able to handle all situations. Therefore, for option 8D, what we're going to do is create a single relation that with all the attributes coming from the superclass and all of the attributes coming from every single subclass. Then we create, for each subclass, create a flag for every single one of that to indicating they belong to this one or not. And therefore, this is actually a very good approach that can handle all kinds of situations. And therefore, step number 8 will be able to handle all the scenarios that we would do the same thing with the first choice. And therefore, you may wonder why there are so many different choices over here. Okay. In this case, the reason that we have so many choices is because depending on the situation, sometimes we may prefer the first one over the fourth one, or sometimes we may prefer the fourth one over the first one. What are those situations? Think about this. For the first one, although it represents a very close design to the original EER diagram, because it has not only the superclass but every single subclasses, it will end up with many tables. When we comes to the query languages, you will understand every time we have multiple tables and we want the information from multiple tables, we need to operate something called join, and join takes time. In other words, option 8D, which has only single relation, we don't need to perform any join operations. It will give you a better performance, but that's readability. So it's always a balance between that. Not to mention, if we choose the fourth choice and we realize that there is only a disjoint scenario, so instead of 8D, I can use 8C, which can handle the situations already. That's why we have multiple choices over here for us to do the conversion. Just know what are the limitations, what are the optimal situations. It's all depending on the scenarios. Finally, mapping of the union. Union gives a very special property because it provides an OR opportunity over here. And therefore, to handle that, we do something very different from all other 8 steps that we have learned so far. So mapping a category which is defining a superclass have different keys indicating they have multiple choices over there. What we are going to do is that we need to create a new relation for this union. But instead of using simply the foreign keys linked back to all the superclasses, we are actually creating what we call a surrogate key to the superclass and use superclass link the foreign keys to the union class. This is something very, very special. Let's take a look at this. So you already know the owner can be a person or a bank or a company. So in this case, what we are going to do is that we know the attribute describing the owners are the names, the bank names, or the company names. So how do we represent this in the relational schema diagram? What we are going to do is that we will have person, entity, bank relation, company relation converted in step number 1 already. So we have those things there already. To handle this union, which lies in the last step, what we are going to do is that we need to create the owner relation and then append owner ID as what we call a surrogate key to all the superclasses, and then use those to form the foreign key refers to the owner ID over here. This is like we creating the ID for every single owner. If the owner, number 1, is a person, then we will have that information, everything over here with the owner ID 1, it will be able to link to our very first owner. So we will know the first owner is a person. If a owner ID 2 is a bank, then we will have the information over here, owner ID 2, to refer back to the owner. The same thing with the company. Say the third owner is a company, then we will have company name, company address, owner ID 3 that will link to the owner. So this is how we will be able to provide the choices of a person or a bank or a company. And that's all because we create the ID for every single owners that we have, and we use that as the foreign key link back to the owner. So this is how we will be able to handle the union operation. So if we look into a bigger picture over here, you can see that the top part is the one that we have focused on. Now the other part, registered vehicle, has another union type. So of course, when we do that, we need to have a car with a vehicle ID links back to the registered vehicle. Truck has another ID attribute form as a foreign key link back to the registered vehicle. And then we will also have this local attributes to the registered vehicle, and then use a M to N relationship to connect the two. So let's take a look of the operations that I have provided over here, and this is the description of what I have just mentioned. So based on this one, you will see for the person, bank, and company goes to the owner. This is something that we already see. For the registered vehicle, you can see that for a car and a truck, they have register ID over here links back to the registered vehicle, which represent another union conversion. Finally, since I have an M to N relationship, remember this is step number 5. What we need to do is that we need to create an owns relation, link the primary key of the owner and the primary key of the registered vehicle, which are owner ID and register ID. Link foreign keys back to those, and the primary key of owns is a combination of the two. Since there are two other local attributes or attributes to relationships, then we include those over here. So this is the full conversion of what we see in this example. That includes 2 union operations plus 1 M to N relationship. So this is like the conclusion of what we can do to convert the ER diagram, EER diagram into relational schema diagram. Finally, I want to give you some assignment. This assignment is pretty straightforward compared with the example we just see. So take a look at this one. This ER diagram, pay attention, this is only a ER diagram that has 3 entities. I want you guys to convert all of this into relational schema diagram. Pay attention to this one. There are 2 multi-value attributes. One is the color of the vehicle. The other one is hours of the branch. So make sure you notice that there are 2 multi-value attributes over here. 3 entities, 2 1 to N relationship, and 1 M to N relationship. So try to convert those into a relational schema diagram. It will take a little bit time compared with other assignments. So please work on this one and submit it through the Blackboard. The last slide I want to show you is a practice I want you guys to work on. You don't need to submit this one, but this is a practice about how do you convert a EER diagram. So in this case, you can see that we have employee, we have a subclass category over here, another subclass. The subclasses can also have some relationships with all other entities. So this is going to give you a good practice of converting the EER diagram into a relational schema diagram. But this is only a practice. What you would need to submit is the assignment slide that is probably much smaller compared with the practice I want you guys to work on. If you have any questions regarding to the assignment or the practice, you are welcome to come to the class online support, and I would be happy to help you with all of this. That would be all for the chapter.